In this lesson, we're going to be learning how to determine domain of functions. So we'll be learning how to find domain of different functions. But before we start, let's learn different ways in which we can represent domain of functions. The first one is interval notation, and it is where you use parentheses or and bracket to represent the domain of a function. So when do we use parentheses and when do we use bracket? We use parentheses when we are dealing with a strict inequality. For example, when you have x is greater than 2. So, and then you use this when we are dealing with weak inequalities. For example, x is greater than or equals to 2. Now, let me show you how you write it. If the domain of a function is x is greater than 2, you use these parentheses and then you write 2, comma, infinity. Now, what this means is that this 2 is not inclusive, alright? So once 2 appears close to this parenthesis, or any number that appears close to this parenthesis, it means that that number is not included in the domain. Now, why parenthesis is covering this infinity is because infinity is not a definite number, alright? So infinity is not a number, it's just like the number goes on and on and on. So that's why it is open, okay? Now, for this bracket, if you want to represent this x is greater than or equal to 2, you use this bracket like this, write it like this, 2, then comma, infinity. So always use brackets to close infinity sign because infinity is not a definite number. Alright. Now, what this means is that this 2 is included in the domain of this function. Alright. So that's why you see x is greater than or equal to 2. Now, another way to represent it is just using this formula of inequality. So x is greater than or equals to 2 is a good representation of a domain, or x is greater than 2 is a good representation of a good domain. Or you can just write it this way. That's, you write it d, then this, and then d, which is domain is equals to this and this. So these are the two ways you can use and represent domain of a function. So let's come back to the question. We asked to find the domain of f of x is equals to root x minus 3 over root s squared minus 4. Now this is a radical function, but let's discuss the base version of these radical functions, the parental function. We have f of x is equals to square root of x. Now what is the domain of this function? Now in this function, f of x is equals to root x. We know that we can't have a negative number inside a square root, but we can have 0, right? Square root of 0 is equals to 0. We can have 0, but we can't have a negative number. So we're going to set what is inside of this square root to be greater than or equal to 0. In interval notation, the domain is going to be 0, infinity. Notice that I use brackets to write this 0 because 0 is included, alright? It's greater than or equals to 0, that's from 0 to infinity. And so this is the domain of this particular function. Now, what if you have something like f of x is equals to 1 over square root of x, alright? Notice that we set this x to be greater than or equals to 0, but in this case, we can't set it to be greater than or equals to 0, because if we do that, we are going to have 1 over 0. But we don't want to have this 1 over 0 because if x is equals to 0, it means that this f of x is going to be undefined. Alright, the domain that we're looking for are the values of x that will make that function defined. So any number that will make a function undefined is not going to be part of the domain of that function. And in this case, if x is equals to 0, square root of x will be 0, and 1 over 0 is undefined. So that's why we can't equate the denominator to be greater than or equals to 0. Instead, we're going to write this as x is greater than 0. Alright, that way we are not going to have 0 at the denominator. Now, if you represent this in interval notation, then the domain of this function is going to be 0, infinity. Now, this 0 is not included. Alright, so with this information, let's solve the domain of this function. F of x is equals to square root of x minus 3 divided by square root of s squared minus 4. Let's focus on the numerator first. Now for the numerator, we know that we can have 0 because this is at the numerator. We can have 0 there. Okay, so we are going to set the inside of this square root to be greater than or equal to 0. So we're going to have x minus 3 is greater than or equal to 0. And then if you solve this, you see that x is greater than or equal to 3. Then let's focus on the denominator. Now from the previous example I solved, I told you that we can't have a 0 at the denominator. And so because this is a square root, we can also have a negative number inside the square root. So we're going to set this inside of a square root, which is x squared minus 4, to greater than 0. Is now going to be greater than or equals to 0. So setting this to be greater than 0, let's solve for the value of x. So we have x squared minus 4. Let's equate it to 0. So we have x squared minus 4 can be written as 2 squared. This will be equal to 0. And then difference of 2 squared, we have that this will be expanded to, or rather factorized to x plus 2, x minus 2. This will be equals to 0. So if you solve each of these terms, we're going to have that x is equals to negative 2 or 2. So these two numbers, or these two answers, are the critical value of this question. Now let's find the region that satisfies this inequality. So we have negative 2 here, our critical values, and we have 2 here. So here is negative infinity, here is positive infinity. We are going to test this region, and this region to know the region that satisfies this inequality. So let's pick a number from this region, which is minus 10 is in this region, between minus 1 and minus infinity. So if you put minus 10 here, you have that minus 10 plus 2 is going to be a negative sign. Minus 10 plus 2 is also going to be a negative sign. Minus times minus is going to be equals to plus. So here it gave us a positive sign, so which is greater than 0. Alright, this positive means that the number we're going to get here will be greater than 0. So let's test number between this minus 2 and 2. So, and this number here is equals to 0. Now 0 plus 2 is equals to 2, which is positive, and then 0 minus 2 is minus 2, which is negative. Plus times minus is going to be equals to minus. So this region gave us a negative. And let's test this region 2 to infinity. Let's choose 10. So 10 plus 2 is a positive number. 10 minus 2 is also a positive number. Then positive times positive is equals to positive. So here is positive. Now because we are dealing with greater than 0, we're going to choose the regions that has positive sign there. So this region here is negative. Remember, this is greater than 0, so it's going to be, we're going to use parentheses. We have negative infinity, comma, negative 2, then union 2, comma, infinity. But this is not yet the domain of this function. Let's continue. We're going to see how we get the domain of this function. Now let's represent all these answers in a number line. So we have negative 2 here, we have 2 here, and then we have 3 for this one, 3 here. Alright, so here is greater than or equals to 3. So let me just represent this with a number line. So greater than or equals to 3. For this part is greater than or equal to, greater than 2 only. So let me represent it like this. And then this one is less than 2. That is from negative 2 to infinity, means that x is less than 2. So we're going to represent it this way. Now what does this tell us? Let's check this region and know if it's going to be defined if you plug this region into this whole expression. Now if you choose negative 10, if you plug in negative 10 here, we're going to get negative 10 minus 3, which is negative 13. And we know that we won't have a negative number inside a square root function, so we're going to discard this region. Now let's test this region, which is between 2 and 3. Let's choose 2.5. Now if you put 2.5 here, 2.5 minus 3 is minus 0.5. So we're not going to have a negative number inside the square root function. So we're going to discard this region. So the only region we're going to accept is this region, which is from 3 to infinity, and this 3 is inclusive. So the domain of this function is going to be 3, infinity. In interval notation, or just write x is greater than or equals to 3. We are still in radical functions. Let's discuss f of x is equal to x minus 2 over square root of s squared plus 4. Now, if you look at this question clearly, you see that this square root, s squared plus 4, there is no number that you plug into this s squared plus 4 that will give you a negative number or 0. Alright, you have s squared plus 4. Any number you plug in here cannot give you 0 or a negative number. So we don't have problem with the denominator of this question. Now for the numerator, we also don't have any problem with the numerator because this x can hold any value and this function will still be defined. So with that, we say that the domain of this function is all real numbers, which is negative infinity to positive infinity. I'll just simply write it as domain is equals to all real numbers. So that is the domain of this function. Let's discuss this one again. F of x is equals to square root of x minus 4 divided by square root of s squared plus 2. Now this is similar to the last one we solved, like the denominator. So here we have s squared plus 2. We don't have any problem here because no value of x will give us 0 or a negative number inside the square root. So let's focus on the numerator. Now because this radical sign is at the numerator, we are going to set the inside x minus 4 to be greater than or equal to 0, since 0 is allowed at the numerator but not at the denominator. So setting x minus 4 to be greater than or equals to 0, we're going to solve for x and it's going to give us greater than or equals to 4. Alright, so this is the domain of this function, or in interval notation we write it as 4, infinity. We have f of x is equals to x minus 2 over square root of x minus 3. I want you to pause this video and try this question. If you are done solving it, you unpause it and check the solution. Now we have x minus 2 divided by square root of x minus 3. We don't have problem at the numerator, but denominator is where we have a little bit problem. So we're going to set the inside of this square root to be greater than 0. Alright, so let's solve it. This will be greater than 3. So this is the domain of this function, or in interval notation is going to be 3, infinity, because 3 is not included. Alright, so now there's another thing I want to discuss on these radical functions. If you have f of x is equals to cube root of x. Now so far this root is odd. Let's say 3, 5, 7, 9, 11. So far it is odd. The domain of the function is going to be all real numbers, which is negative infinity, infinity. But if it is an even root, let's say f of x is equals to square root or 4th root or 6th root or 8th root of any number, then it's going to be x is greater than or equal to 0. But that's if it's standing alone like this or at the numerator. If it's at the denominator, it's going to be only x is greater than 0. Then interval notation is going to be that the domain of this function is going to be 0, infinity, because 0 is included. Now for linear functions, for example, f of x is equals to s plus 3. For any linear function, the domain is negative infinity to infinity, because any number you plug in into a linear function, you're going to have an output, which makes that function to be defined. Now let's focus on quadratic function. Let's say we are given f of x is equals to x squared plus 3x plus 2. Then the domain is going to be negative infinity comma infinity, because this x here can hold any value and still give an output. So that's why the domain is all real numbers. Basically, all polynomial functions, the domain is all real numbers. That's negative infinity to positive infinity. The next one is absolute value functions, which is of the form like this. So the domain is still negative infinity to infinity. That is all real numbers. So the graph looks like this. So it's open upwards or can open downwards. But then the domain of this function is all real numbers. That's negative infinity to positive infinity. Thank you for watching. Please don't forget to subscribe to my YouTube channel, like this video, and share with your friends. Have a nice day.